Good morning, afternoon, evening, or wherever you are. Today, I and Atha will explain about kinetic molecular theory, which is a theory of how does gases particles work within a system.
In this video, we'll explain the 5 postulates of kinetic molecular theory.
So, what are the 5 postulates? First, explain.
Now, this square thing right here, is a container.
Assume it.
Assume it as a container, yes. And in this container, there is a gas.
In an empty space.
Yeah, these particles here are moving in different directions, but they have constant motion. This is an example of the first postulate, where the particles in a gas have constant motion and are going in random direction. Now these particles, see, they are far apart from each other. Their distance is quite a large distance. If so, what fills this space? Nothing. This is empty space. The rest is empty space.
And that is the second postulate, which is kinetic molecular theory actually had an empty space.
There, and the empty space separates the particles from a gas from each other. These particles assume these particles are hitting the sides of the container. Every time they do that, they exert pressure. This is an example of the third postulate, where pressure is the amount of times the gas particles hit the side of the container.
And the fourth postulate, so the particles collide with a perfectly elastic collision.
But this is only assumed so, because this is actually a property of an ideal gas, where the particles do not interact with each other and just perfectly elastic collision. Now, you see these particles moving, right? These particles have kinetic energy. Kinetic energy. All the average Ke in this gas, it's called temperature. That is the fifth postulate. The temperature is the average kinetic energy of all the particles of a gas in this container. Next, Farel,
Hassan, and Rafa will explain about the 4 laws of thermodynamics. But before that, we'll make a summary of gases' 5 postulate.
The particles are in constant random motion, and what separates them is empty space, which makes up most of the gas. When the particles collide with the container, they exert pressure on the container. We assume zero interaction between particles, and their collision is perfectly elastic, and the average kinetic energy of a gas is proportional to its temperature.
For the next part, Farel and Rafa will explain the 4 laws of thermodynamics. Off to you, Rafa.
There exist 4 laws of thermodynamics. So starting from the first one, which is the zeroth law. The zeroth law of thermodynamics deals with the thermal equilibrium, which describes two net heat flows be between two systems. If two systems are in thermal equilibrium within a third system, then those two are also in a thermal equilibrium. So you may wonder, why is it called the zeroth law of thermodynamics, even though it is being the most first law of thermodynamics being mentioned and implemented? So this goes down back in history, and around the year of 1930s, scientists were trying to draw a conclusion on what they should name this specific term of a law of thermodynamics. So then they thought that it was so important that it should go down all before the rest of the other laws, hence being it termed as the zeroth law of thermodynamics. Not long after that, a physicist by the name of Ralph Fowler finally established it, making it recognized as a part of the law of thermodynamics. Alright, so the next law should be the first law of thermodynamics, which is found by Rudolf Clausius and William Thomson, or better known by Kelvin, around the year of 1847. So, going against the main case of this law, which goes against Rudolf Clausius, Clausius had several experimental evidences of this following law. Those are not coming from his own experiments, but rather going ahead against the unit joule itself. So the first law states something about the equivalence of heat and work. So the following says that whenever work is done, an equivalent amount of heat is consumed.
So, for the second law of thermodynamics, it states that the total entropy of an isolated system can never decrease over time. In simpler terms, it suggests that in any natural process, the overall disorder or randomness, known as entropy, of the system and its surrounding tends to increase. This law helps explain why certain processes, like heat flowing from a hot object to a cold one, occur spontaneously. About the third law of thermodynamics, it states that as the temperature of a system approaches absolute zero Kelvin, the entropy of the system approaches a minimum value. In other words, as a system reaches absolute zero temperature, its entropy also approaches a minimum or zero value. This law is significant because it sets a limit to how cold a system can get and helps define the concept of absolute zero. That is all for the 5 postulates of kinetic molecular theory of gas and the 4 laws of thermodynamics. Thank you for watching and goodbye.